subnet masking. So let's start with the subnet masking. Let's see what is subnets within a network or within an organization. So subnets is basically when is derived from a word that is known as subnetworks. You can see that this is basically nothing but sub networks. It means that if you have a network, you have created a network and you want to further divide your own network. This is not external network, this is your internal network, and you want to divide your own network that is a license to you so that you can use it. So if you want to divide that in, let's say, two parts, so this is one network as a whole, but for outside, for outside world it will be one network, but inside you have actually divided it into two. That is basically subnetting, because internally there are two networks but the outside world doesn't know about it, and there are several reasons for using that. So we will discuss that in the coming slides, but for now this is enough for you that basically subnetting is when you create multiple networks within one network. You divide a big network into small chunks or small networks within the same network, and this is very beneficial actually, and we will discuss that now. Subnet is basically a subset of the entire network. Every subnet combines to form a big network. Let's say there's a big network and you have divided this network into, let's say, two network. Again, this is the first network and this is second network, and the whole network name was, let's say, A. So this has become A1 and this has become A2. So A1 and A2 are the subsets of A, the entire network. So networks can be divided into subnets, and subnets can be also divided further into subnets. Let's say if you have divided this A into one A1 and A2, and similarly this 2 wants to divide its own network within its own region, that is like here. So this subnetting is also possible, and this subnetting will not be visible to this network, this outside network, and this subnetting will also be not won't be seen outside from this network. Let's say there is another server B. So server B won't be able to see the subnetting inside A. Similarly, A won't be able to see subnetting inside 2A. So this is how you can divide a network into subnetworks and further classify the subnetworks into more subnetworks. So each subnet is basically treated as a separate network, but for its own region. As I've already told you that for A, this will be two regions, and for B, it will be only one network. Outside world will not be able to see it. This will consider this all as a same network, but inside this A will treat them both as a two different networks. Similarly, this two will create this two will, let's say, this is small a and this is small b. So this, for this two, this won't be the same network. It will further divide itself. So if the packet comes in from A to 2A, so this 2A, 2 capital A, will divide this, will have to look that which direction the packet should follow, either towards B or either towards A. So let's see how this actually works, and it can be implemented excuse me, and this subnet can be implemented on a WAN or a LAN. So this is basically achievable on the LAN and WAN. So here is a you can say Venn diagram of the subnet. You can see that this is a whole network, and this whole network is divided into 4 subnets. And I will tell you what are the benefits of subnetting. Let's discuss the benefits of subnetting. The benefits of subnetting is basically if you want to have some privacy, the number one thing is that you want to have some privacy. Let's say you do not want let's say this is your university, and university doesn't want the students to be a part of such information system that is confidential. So university will create a subnet only for student, and this subnet will be only for students. Similarly, if a university wants to create a subnet but with some more privileges, let's say for faculty, so will be for the faculty as well. This will be for the faculty. This subnet will be just for the faculty. This is for the students. Similarly, if there is some administration purposes, so there will be a network that will be looking for this administration purposes. So let's say subnet 3 is justified and allocated to somewhere of the administration who will control that administration. And let's say subnet 4 is reserved for, let's say, distance education. So all the data of different departments will be, let's say, of distance education will be dealt over here. So due to this, you can see that a privacy has been achieved, a security has been achieved. Privacy or security, these both are synonyms. So you can see that you have achieved the privacy or you have increased the security level. Number one. Number two, I've this also causes reduction in the delay, because let's say if you have allocated the subnet 1 as for students, so the packet coming in for the students won't be looking for the student in these networks. He will know the packet or the router will this is the router that has that is the gateway from the for this network. So the gateway that is router, it will obviously know that the students are allocated in this region, so it won't be finding the student over this networks, so it will cause less delay. So delay is reduced by doing such a subnetting. A kind of delay has been reduced. Number 3, you know that if we divide a big thing into small networks, it is very handy, and the complexity level becomes very less, so it's more simple as compared to a big giant network. So simplicity, or you can say less complexity, is also a benefit for this kind of division of the network. So this is very beneficial, and you can achieve many more benefits from such kind of subnetting or such process that is known as subnets. Now, I have already discussed about the CIDR in the previous class, that how we can achieve classless interdomain routing. The same principle will be applied over here. Let's say there is a typical class IP address. For example, this is IP we have given, and you can see that you already know that there are two parts of this IP address. One is the network ID part, and other is the host part. You can see that this is basically the network ID part. For example, this is example, and this is basically the host ID. So let's see how a subnet is created. So subnet is basically creating by using the host ID. You can divide a host ID into some kind of bits, and that bits will specify the subnet number. And we have already discussed in the previous class about slash, let's say 25 or 26. If we have placed slash 26, it means that 24 bytes was allocated for the network ID, but these additional 2 bits have been allocated with this as well, and this slash 2 represents there are 4 subnets, because you know that increasing of 2 bits creates 4 different options: 00, 01, 10, and 11. So it means that you have divided your network with your own into 4 subnets. Similarly, if you want to divide your network into 5 subnets, minimum 5 subnets, so you won't be able to achieve that with these 4 options. So you will have to increase this 26 to 27. So by increasing 1 bit, you will have 3 bits over here instead of 2, and using 3 bits you can have up to 8 different subnets. You know that start from 000, and if you go to 111, these are basically 8 numbers. So you can have up to 8 subnets within a network. So this CIDR is very beneficial, that we have discussed in the previous class, that how you can achieve or how you can find the mask basically. So this is your mask slash 26. This is your mask actually, subnet mask. This provides you about the information of subnets, and we have done several numericals in the previous class as well. Now let's look at example. This is let's, for example, if we want to divide a network into 4 subnets, the same example that I did in the previous slides. So this is example mentioned over here. We can use the following schemes. 4 subnets represented can be represented by 2 bits. You know that 4 bits, 4 subnets can be represented by 2 bits actually, because the combination of 2 creates 4 different combinations. The use of 2 will be giving you combination of 4. So for a class B address, let's say there is a class B which already have 16 bits. You know that class B address has 16 bits of network portion. So if you want to further create 2 or you can say 4 networks within that network, so you will have to assign 2 more bits to that 16. So the total network ID will become 18 bits. So instead of generic class B IP with no CIDR, you have to put slash 18 at the end. So it will show that 16 bits are reserved for the network side, that is network ID, but this additional 2 bits will be used for subnetting. There will be 4 possible combinations: 00, 01, 10, and 11. So this will have 4 more networks within same network, that is of class B. Another example, another benefit that I didn't mention over here was the use of subnetting increases your basically multiple options for different networks. You, in this case, you have increased the networks, but there is a cost that you are going to pay. Network quantity you have increased by yourself to achieve these things, that is privacy, delay, and simplicity. But the disadvantage of such things is basically uh, the users. You have actually reduced the users, because the last bits of any IP address is basically users. That how much users you can, that is host ID. You know that this is host ID, and if the host ID have more bits, you can have more users. But if you are allocating some of the user bits to the subnetting purposes, let's say you have this is 8 uh, bits in the last byte, that is user host, and 1 2 3 4 5 6 and 7 and 8. So you have divided your network, but you want to have 2 or 3 more networks within your own network. So you will have, you will be keeping these 2 for the subnetting purposes, that is slash 18 in the case, or slash 26 in the case of class C IP. So you will only left with 6 bits. So it means that each subnet will have 2 power 6 users. Means with 01 there will be 64 sorry 00 in the, let's say this is 00, this is 00, this is the name of the network, a subnetwork basically, 01, 10 and 11. So each of these will have 64 users, because they have combination of 6 bits. So 2 power 6 becomes 64. So 64 users will be company over here. 64 will be allocated over here. 64 will be allocated over here, and you can, the maximum limit that you can allocate basically 64. And you know that the start, all zeros and all ones cannot be a part of the network host, basically host users. So you will have to minus 2 IPs. So you will have to you will remain with 62 basically users. So 62 users will be available over here, 62 users will be available over here, 62 users will be available over here, and 62 users will be available over here, because you have subtracted 2 IPs basically, that is all zeros, that is represented that is allocated for the identity of this thing, and all ones that is used for the broadcasting within these all the subnet. So these IPs will be uh, reserved for such purposes, and when you minus 2 IPs from 64 addresses, you get 62 addresses. So maximum users then you can allocate to any of these subnet becomes 62. So this is very useful example if you want to understand the basic phenomena of subnetting. So let's see about the external routing with subnets. So as I've told you, subnetting is not something that is visible to outside. So it is basically transparent within an organization, but outside it won't be, the outside network won't be able to see it. So you can see that if subnetting is used in a university, routers that are outside university will not consider subnetting at all, because they won't know, because this is an internal thing that a router or a gateway of a network or subnetwork does by itself. So if you have you have a network, and you have a router that connects you with from to a network, so you can have multiple networks, and outside the router there won't be any problem for you, because the outside world won't be able to see it, that you have divided your network into subnetwork. And when let's come talk about internal routing with subnets. So when a packet enters our network with subnetting, the routers will behave differently. Let's say let's go back to the example, and let's let's keep it, and let's say I should have changed a color. Let's say this is visible. Yeah, this is right. So let's say this is the router, and a packet comes, let's say for subnet 2. So the router will see that which IP, let's say this was uh, 11. So the router will see the first two bits of the last byte. So if it is 11, it will directly send the packet to this subnet. If is 01, so the router won't be sending this packet to subnet 1 and subnet 2 and subnet 4. It will directly send this packet to subnet 3. This is the router which is dealing all this subnetting. So the router that is operated at network layer, we have already discussed that why this network layer is so important, because all the security breaches and all these things occur mostly at the network layer. So this router is placed as a network layer device. So it will be responsible for such activities, and it will create a path or route a packet from the router, that is gateway, and it will send directly to the subnet that the packet belongs to, and it will route the packet towards the specified user that is specified by the last 6 bits of the IP address. And we have done a few examples in previous class as well. That was the fifth lecture, first part of the fifth lecture. So you can see that a route may be used to use the subnet ID, that is network portion, plus the subnet portion followed by the zeros to determine which route to take. So I have already told you that you have to basically put all the zeros to find the value of the subnet. So if the packet comes in and you know that if it is a 00, so you can easily put all zeros in front of this, and you will able to find the subnet number, that which packet does it belong to. Let's see a good example. This is the IP address that is mentioned over here, that is 137.207.177.10. So if you, and this is a subnet mask, let's say uh, 137.207.0.0. This is the mask. So if you this is the outside world, and if it's sending the packet to this internal router, you can see that these are external routers, and this is your internal router. So the packet will be coming over here, And this subnet, this internal router, will see that the first bytes is corresponds to what. If it is 00, it will send the packet towards this side. If it is 01, it will send the packet to this network. If it is 10, it will send the packet in this network, and if it is 00, it will send the packet at this side. So this is very cool stuff if you want to do this thing. So this is example. This is the internal routing. You can see that this has summarized the previous two slides. This is your internal routing, and this is your external routing. Outside the your organization or your network, they won't be able. These routers won't be able to see the networking that you have done using this router. So you can see that these are the first two bits that were assigned for the the router has kept these two bits excuse me for the for the sake of subnetting. So if the packet comes in, it will automatically AND these things, and you will be able to find. I have done a few examples in the previous class, and let's discuss it in a very brief manner in tomorrow's class, inshallah. So it will AND these things, and after adding, it will fall about this and this, and 10 and 11. It will find the route that which packet, which subnet does the packet belong to. It will just create a binary digit with all zeros. I've already told you that these first two bits are kept for the network subnetting purposes, and the remaining 6 bits will be for users. So the packet, you can see that now when it was ended with this IP address, so it found out that this packet belongs to this 10, because you can see that this is 10 and this was also 10. So if you add this thing with this number, and so you will find that this packet belongs to subnet 3 because of the use of 10. So the packet will be coming towards the third subnet. Actually, the packet which was originated by the external router somewhere, now it has reached its destination, that is subnet 3. So what is multi-level subnets? This is the concept where you divide a subnetwork into more subnetworks. You can see that this was your whole network. You divided into 3 different subnets. But in subnet 2, there was, let's say, things that were also very blurred, and you want to clear some things, and you want to allocate different users into a different network for the sake of security as well. Let's say I have divided the students group into undergraduate and postgraduate. So I have to create something for let's say MS PhD students. This is for PhD students, and let's say PhD students are given with more bandwidth. So I can not give the bandwidth to these BS students. I want to give more research resources and, let's say, coding to specific users, or more resources or more bandwidth to specific users. So I will keep these PhD students in the subnet 2A, and the BS students will be having less, or you can say a different kind of resources. Resources will be different for BS students. So this is your BS students. So I have kept or allocated the BS users into subnet 2B, and for higher studies I have divided the students into PhD. So you can see that I have further classified. So this is known as 2 level of subnetting. Similarly, you can also have 3 layers or 4 layers or as many layers as you want, but the more layers you get, the more complexity you are creating. It is very easy to be it is very easy to understand that number of levels will increase the number of simplicity, but you will also have a very complex, or the cost or that you will be pay is will be the computational cost. You will have to pay the computational cost because and this will also automatically creates complexity. But these are machines, and nowadays there are several protocols, routing protocols that are very efficient, and we will discuss that inshallah in the coming lectures as well, that how this this complexity or the cost estimation is reduced for this kind of layers, because you know that if you have divided into many layers, you will be it will be very easy for you to find a specific. Let's say if I want to talk about only or talk to only BS students, so I will know that my network packet won't be going over here, will not be go over here, will, won't be going over here, it will only go in this direction. So I will know about the things, but the ANDing and ORing and the routing will become more and more, so your complexity cost will be increasing, but overall the structure will be simple. So it will be less delay in the network, and you will be able to find your destination very easily because of these multiple divisions. Similarly, if you want to increase your layers for a layer 3, a layer 4, and you want to further classify this into further networks, you can also do that. But again, you are increasing the computational cost, that ending and let's say the routing purposes, you are basically increasing the computational cost. The time required or the energy required for the computations will be increased. So this is an example that I've already discussed in the previous classes, previous class actually. There were 3 or 4 examples in which I use CIDR, and you know that this is basically CIDR. You have to put /28 /26. They are another. These are other common class B subnet masks. You can see that if you want to have 4 subnets, you can actually allocate. You can see that you have allocated 2 bits over here. Similarly, if you want to create 4 subnets, or not 4, you want to create more than 4, let's say 16 subnets. 16 subnets means there are 16 subnets, so you are uh, putting 4 ones over here. So it will be generating 2 power 4 16 networks within a network. So the cost you are going to pay for this is basically the number of users. You have actually reduced the users, because now you will be remaining with 2 power 4 users minus 2 IP address that is allocated for the broadcasting and network ID. So 2 power 4 is 16. 16 minus 2 becomes 14. So there will be 16 networks, and each network will be comprised of maximum of 14 users. So the total users that you will be having, you can have in your entire network will be something that is the product of 16 and 14. Similarly, if you want to go with higher subnets, you want to have more networks within your own network. So basically, you will divide your network into further. Let's say you want to achieve 64 networks within your own network. So you have to specify 2 power 6 bits. You have to allocate 6 bits. 1, 2, 3, 4, 5, 6. These are the 6 bits, and using these 6 bits, you are achieving a 64 network. Basically, you have divided your network into 64 networks. You can see that you have divided very much 8 cross 8. This is basically a chessboard of 8 cross 8. So now you can see that how much difficult it is. The structure of this network, it seems difficult, but it is very simple, but the computational cost will be increased. Now you can see that if you have 64 networks, so in each the size of the network or the area of the network has been reduced. You can only accommodate 4 users because there are 2 bits remaining. So the maximum number of users in each network will be 4: 00, 01, 10, and 11. So there will be 64 networks, and each network will be comprised of 4 users, but these you can see that these IPs will be allocated for reserved purposes, and each network will be comprised of 2 users. So you are achieving 64 networks with 2 users in each network. So now you can see that you are receiving very much less users. The total users that can be communicated over here is 128, and you can see that if you multiply 16 by 4, I'll show you, see what is the answer. 224. So in this kind of where you are reducing your networks into very small networks, this is basically 224. Yes. So the number of users that will be allocated if you are using 16 subnetworks. So the total number of users within this network will be 224. Similarly, if you are dividing a network into 64 subnetworks, so the number of user has been reduced very much. So the more subnetworks you are generating, the less users you are accommodating actually. So this is a thing that is introduced as classless interdomain routing. Interdomain routing. We have discussed it about in the previous class as well. So this is basically the concept of CIDR. There is no class because you have actually taken the IP of class C or class B or class A, but you have adjusted your own bits within it. So this is achieved by CIDR. And we have already discussed that what is CIDR. You have to put slash 26 slash 28 slash up to so on. Maximum limit is basically 20 32, but you cannot allocate all the bits to the network side, because if you allocate slash 32, there will be no users in every network. So this will be network, but there will be no users because there is no space or no bits remaining for the users to be named as. So this was all about today's class. I hope you have learned very much, and I wish you best of luck and for your questions, and I look forward to them. And if you have any questions, you can write it down and discuss it with me in the class. And you can also comment down and ask your question in the comment section as well. I will be seeing you in the class. Thank you very much. That's all for today. Allah Hafiz.